All right, let's take a look at our second example for Hess's law. And just like the first one, I've been given a target equation, and I've also been given two reference equations that I need to use to try and figure out the delta H of this target equation. Again, I just sort of rewrote this to give me a little bit of extra space to show my work. But essentially the steps are the same as the first one. I want to compare each reference equation to the target equation to see if I need to make any changes, right? So looking at the first one, I'm going to compare. I have a bunch of these are the same. So I know that there's CH4 gas, The coefficient is the same, and it's on the same side of the arrow. They're both reactants, so that I'm good with that. Moving on to 2O2, so oxygen gas. I've got both have the same coefficient and they're both on the same side of the arrow, right? So I'm happy with that. I have CO2 gas, again, same side of the arrow, so they're both products and they have the same coefficient, so I'm pretty happy with that. Now, for the last one, I have 2H2O liquid here, but in my target equation, it's 2H2O gas, right? So that's not the same. So although this reaction is very similar, it's not exactly the same. Now, but comparing all the things that I do have the same, I don't think that I need to make any changes. So I'm just going to write it as -1. Sorry, +1. Multiply by 1. My second equation, H2O liquid, that's not in this reaction, but I have H2O gas, right? And taking a look here, comparing H2O gas here to the H2O gas here, the coefficients are not the same. While this has a coefficient of 1, this has a coefficient of 2. They are, however, on the correct side of the arrow. So what I'm going to need to do is I'm going to try and make this change so that this ends up with the same coefficient as that, right? So I'm going to multiply this by 2. So what I'm going to do now is write out these reactions with the changes that I want made and see if that adds up to my target equation. So CH4 gas, so that first equation does not have any changes, or I don't think there should be any changes. And some of this is trial and error. So you might see in some of the other questions that we might do, you might have to try one thing and then come back and try another thing, right? But in this case, I don't need to make any changes to this first equation. So I'm going to leave that as is. For my second one, I said that I would multiply it by 2. And when I'm multiplying it by 2, I want the coefficients to be multiplied by 2. They both have a coefficient of 1. So when I write that over, so equation number 2 is going to have 2H2O liquid gives you 2H2O gas. Okay, I'm going to try and cancel out whatever I can before I combine these reactions. And I see that I have 2H2O liquid on both the reactant side and the product side. After that, I'm just going to add up and see if this is exactly my target reaction. 2O2 gas gives you CO2 gas plus 2H2O. So if you see here, this is exactly my target equation. So I'm pretty happy with that. The only thing I have left to do is account for these differences in these numbers and add them up to find my target, the delta H for the target equation. So the delta H for the first one did not change. So -890 kilojoules per mole. For the second one, I did multiply those coefficients by 2, so I would need to multiply this delta H by 2 as well. So the delta H becomes 88 kilojoules per mole. And when I add both of these delta H's up, I'm going to get -802 kilojoules per mole. right? And I was able to add these up because I know that these two equations add up to form our target equation. The only difference here that we made is we multiplied that second reference equation by 2, and I represented that when I did the delta H, I multiplied that by 2 as well.